Okay, everyone, so for the summer work test, I'm going to go down, I'm going to talk about the format of the test and the most important things that you need to know for the test. So to start off with the format, we're going to have 10 multiple choice questions. And these are not written by me. These are like AP style questions. Alright, so there's only going to be 4 choices, A, B, C, and D. And I'll be honest, the majority of these topics have to do with motion graphs. So predominantly position versus time. And velocity versus time graphs. Okay, so you should be able to compare like 2 different velocity graphs. Okay, so we can talk about the different types of curves of those graphs in a second. And to go from one to the other, so to be able to go from position versus time to velocity versus time. Okay, so this is multiple choice, so you might have to be able to recognize which 2 are actually correct of each other. That alone is honestly about 6 questions. So just motion graphs in itself, I'm going to say basically 6 questions just on that. So definitely make sure you know that. Okay. The remaining 4 are more to do with motion diagrams. So there's like about 2 on motion diagrams. It's not motion graphs, but motion diagrams. So kind of like the particle model. Okay, so make sure you know how to read these. And actually, there's actually 7 motion graph questions. Yeah. So definitely make sure you know that. And then we have 1 question on free fall. Okay, and that's something I might want to spend some time on. Okay, so let's spend some time on free fall for a little bit. So we did the lab yesterday. Okay, remember this is uniform acceleration, but let's just try to think of someone who's going to be dropping something like from a high place. I'll make his hand a little longer. Okay, so if someone's like dropping a ball here, at t is equal to 0, it's at rest. And let's say this is 1 second later. This will be t equals 1 second. All right. After 1 second, what would be the velocity here? So the velocity here is 0, velocity in the y direction. Remember that our acceleration is going to be a constant negative 9.8 meters per second. Meters per second squared. So the velocity at that point is minus 9.8. Okay. So even though acceleration is constant, of course, that means that the velocity is changing. So 1 second later, that velocity has increased another 9.8 meters per second. So now it's minus 19.6 meters per second. Okay? So one thing that I want you to notice is, why do you think that I didn't, why is this distance here, it's supposed to be a different color. Why is this distance longer than this distance? So it's the same time interval, right? But it's going to move a larger distance, larger vertical distance here, because it's moving faster. Okay, so that's sometimes something that people confuse. A lot of times people confuse uniform acceleration and uniform velocity. Very, very different. Okay, so we might do a proof here using our kinematic equations. Okay, so let's compare these two distances. So I'm going to call it delta y1 and delta y2. So let's look at what delta y1 is. So for your kinematic equations, there's x's in these equations, and that signifies for the x-axis, but we can interchange the x's and the y. So if I want to find y1 is equal to y0, so y0 would be the very starting point, the position at t is equal to 0, plus our initial velocity at 0, which was 0 meters per second, time difference is 1 second, and then we have our plus 1/2 minus 9.8 meters per second squared, and then 1 second squared. Okay, so this initial position here is also 0. So we can find that y1 is just going to be equal to negative 4.9 meters per second squared times 1 second squared, which is equal to minus 4.9 meters. Okay, so this distance, this is 4.9 meters below the person's hand. Okay, so a falling object will move 4.9 meters in 1 second, that first second. Okay, but if we now look at from seconds 1 to second 2, so this last part, so this will be y2 is equal to y1 plus that initial velocity at 1, okay? And there's still only 1 second difference there. And then we have our 9.8. And still just 1 second interval here. Okay, so y2 is equal to minus 4.9 meters plus my velocity at y1 is negative 9.8 meters per second. 1 second. And then I'm going to go ahead and simplify this to 4.9 meters per second squared times 1 second squared. So we get minus 4.9 minus 9.8 meters minus 4.9 meters. Okay, let's look at our units here again. So if you don't understand units, let's look at this. So obviously the units here is meters. Here we have seconds in the numerator, seconds in the denominator. They cancel out. Here we have meters over second squared, and then we have second squared on the top. So sorry about that. This is kind of the only way I can write it right here. So those will cancel out because this is second squared. So we get our units. And this is minus 19.6 meters. Okay, so in that first second, it only moved 4.9 meters. From second 1 to second 2, it moved another 19.6 meters. Okay, so let's just kind of think about that for a little bit. Okay, so there's a short kind of conceptual example there. Okay. I feel pretty confident with you guys with motion diagrams, but with graphs, okay, let's start with position versus time graph. Okay, so I can use this. So I feel pretty good with you guys with something like this. So this would just indicate constant velocity. It's a straight line. Okay, and that means that it's moving to the right, so the positive direction. All right, so that's the simplest you could have with a position versus time graph. I feel pretty good with you guys about that. If we have it moving in the opposite way, okay, that means it's moving left at a constant speed. Okay. If it's like this, it means it's moving right. It is accelerating, so it's speeding up. Okay, remember we can tell that because the slope is increasing. Velocity is slope on here. And if we have a similar one in the opposite direction, that means it's going to be moving left. So that would mean it's moving left. Okay, what if we have kind of a combination of the two? So what if we have something like, let's say I'll make up a number, let's say 4 seconds. Okay, so this would show me that this part, acceleration, and it's moving to the right. And then here, there's no acceleration, and it's still moving to the right. Okay, and that change happens at 4 seconds. So you should be able to tell the quadratic part from the linear part of the graph. Okay, let's do another kind of conceptual example. Okay, so remember the slope is your friend here. Okay, so moving right at a constant velocity. At this point, changes directions. So it's going to turn around. It's moving left here. It goes past the origin. Remember, this is the origin here. And then right here, it turns around again. And it's going to move right and finishes at the origin. So what's kind of funny about this example is there's no displacement. Displacement is equal to 0, starts and finishes at the same point. Okay. All right, let's go to velocity versus time graph. All right, let's start with some basics. If it's a flat line, or I'll use a straight line, that means constant velocity. Okay, so let's break this up. So remember, you're going to see these dotted lines here, these like to prevent vertical asymptotes. And yes, I know it's quite impossible, but this is an example here. So this is, you're moving right, constant velocity. Here you're moving left. Okay, now remember, we can tell the displacement of a velocity versus time graph. So what I could do is find the area under here. So if I knew the speed here, let's say this is 10 meters per second, and this point here happened to be 2 seconds, let's say, I could find this area under here would tell me how far it moved to the right, where then this area, this would tell me how far it moved to the left. Okay, so if I just kind of make this point 4 seconds, okay, so we find the total displacement from 0 seconds to 4 seconds. Okay, so we're going to do, and this will be negative 10. All right, so we'll make this easy. So 10 meters per second times 2 seconds plus, and then minus 10 meters per second. And then this time change is still only 2 seconds, from 2 to 4 seconds. Okay, so I think you can see that the answer here is going to be 0 meters. Okay, but if anything is below the x-axis here, that means it's moving to the left. So you do it, you draw really like above the curve in that point. Okay, so you might get something where it's not, where there is some acceleration here. So definitely feel free to pause the video. I'm just trying to save some time. So if you had something. Okay, so it's kind of 3 parts to this. Okay, moving to the right, positive acceleration, speeding up. Here, constant speed. And then remember, you're still moving right here. Okay, you're slowing down, but you are still moving right. If this velocity is positive, you are still moving right. Don't get that mixed up with the position versus time graph. Okay. So we'll say this is 2 seconds, 3 seconds, and we'll make this 5 seconds. And that maximum velocity will be 10 meters per second. Okay, so this is pretty simple. Find the area of this triangle, the area of this rectangle, the area of this triangle, and you just add them up. So remember, please remember your elementary geometry. 1/2 base times height. So plus 10 meters per second. And there's only 1 second between 2 and 3. And then plus 1/2 10 meters per second times 2 seconds. Alright, so that's 10 plus 10 plus 10 gives you 30 meters. That would be the displacement from 0 seconds to 5 seconds. Okay. Last thing with free fall is let's look at the graphs of free fall. Okay, and let's kind of work backwards. Let's look at an acceleration versus time graph. This is meters per second squared. This is time. Okay, so remember, this is a constant negative value. We know it to be, minus 9.8. Okay, that would be the acceleration graph, constant acceleration. The velocity graph, well, if it's constant negative acceleration, it's going to have a negative linear slope, like that. And so based on the time, you would be able to find out the speed at that point, the velocity at that point. And then finally, the last one, to be quick, so that this would be technically y. This would be quadratic. Okay, so this signifies constant negative acceleration. Okay, awesome. All right, really, so then after the multiple choice, it's going to be 2 free response questions. The first one is pretty similar to the worksheet that we did in class with the drag racer. Okay, make sure you can convert units. The conversion will be given to you, so you don't need to worry. And be able to use your kinematic equations. Okay, you'll have the worksheet, or I mean the equation sheet. You'll have to find displacement vector, just like how we did with the other one. You will have to draw a particle motion diagram. Okay, my biggest tip for the particle motion diagram is do not get lazy. This is where people lose most points. It's by getting lazy. So remember to label your time intervals. This will be reminded to you in the instructions. Velocity vectors, acceleration vectors, and if you can, some sort of scale with displacement. Okay, the second free response question is, it's more kind of like a straightforward kinematics problem. Okay, part of it is going to be constant speed, part will be constant acceleration. Okay. So here, using kinematic equations, there's only 3 that you need to know how to use. Okay? It's very important that you know when to use them. Okay, it's easy, just list out everything you know and figure it out. Okay, afterwards you're going to plot a sketch of a graph for the motion. Okay, so this is going to show me that you know not only how to recognize motion graphs, but how to create your own from the data given to you. Okay, so all in all, if you had to study anything, the 2 most important things would be knowing how to use your kinematics equations and motion diagrams, or like graphs, motion graphs, so velocity graphs, position graphs. Next chapter is going to be very vector heavy, so that's why there was a lot of summer work with vectors. For this task, really the only vector part is the displacement vector part. Okay. All right, hope this helped. Good luck. Bye-bye.